Hello everyone and welcome to this video. In this video we are going to be talking about this particular integral over here. Now this is a very interesting integral because when I tried to solve this using traditional methods, I couldn't. So that made me wonder if it was possible to solve this particular question by using something different. Now that is exactly what I'm going to be teaching you today. And our topic for this video is going to be the King's rule. Now, this is a very interesting sounding formula, I guess you could say, or theorem, I guess, in calculus. Now, essentially what this rule states is that if we have a definite integral from a to b of the function f of x with respect to x, then this is essentially equal to the integral from a to b of the function f of a plus b minus x dx. Now, this is the reason that it's very interesting, and if you want the proof for this, you could take a look at the internet or really any calculus textbook out there, because many of them do have proofs of this. This video is just going to be a short introduction to the rule and how we can apply this rule into various questions. Now, this is essentially what the rule states, and we're going to be using this exact thing to solve our original question right over here. Now, I guess we should get started. So, first of all, let's denote this integral as I. Now, using King's rule, we can say, using King's rule, we have that I is equal to the integral of pi from 0 to pi. So now first we have to figure out, since our function is f of x, which is x times sine of x over 1 plus the cosine squared x. Now this is f of x, and for this particular question right over here, a is equal to 0 and b is equal to pi, which would mean that f of a plus b minus x would just be the f of pi minus x. Because of this, our term right over here, our expression, is just going to be pi minus x instead of the x's. So pi minus x times the sine of pi minus x over 1 plus the cosine squared of pi minus x with respect to x. Now what we can actually do is add this I into this I. So essentially what we're going to have is 2I, which will be equal to the integral of pi integral of 0 to pi. So what I'm going to do here is I'm just going to skip this step, and you can see that the difference is, so this one becomes the integral from 0 to pi minus x times, so we know that sine of pi minus x is just sine of x over, and the cosine squared of pi minus x is just 1 plus the cosine squared of x dx. Now we're going to add this and we're going to add this. Now you'll notice that the only thing that's really different over here is this term. Over here it's just x, but over here it's just pi minus x. And when you add these two together, the x's cancel out and we are just left with the pi one. So pi times the sine of x over the 1 plus cosine squared of x dx. Nice. So what we're going to do is we're just going to leave an I over here, so 1 over 2. Actually, let's take the pi out from over here as well. So we're going to have pi over 2 times the integral from 0 to pi of sine x over 1 plus cosine squared x dx. Nice. So now what we're going to have to do is we're going to have to use some u substitution. What we're going to do is we're going to let u be equal to cosine of x. When we differentiate u, we will get minus sine of x, which will then mean that dx is equal to du over minus sine of x. Now, using this u substitution, we can write over here that I is equal to pi over 2 times the integral. Now, for the substitution to actually work, we also have to rewrite the limits. So for the upper limit, we have pi, and for the lower limit, which we have 0. Since this is the case for x, and for u, since u is equal to the cosine of x, we're going to have to write this limit as u as the cosine of pi, which is just -1. And for the lower limit, we're going to have the cosine of 0, which is 1. Nice. So we're going to write this as the integral from 1 to -1 of. Now, so we have sine x over 1 plus u squared du over sine x. Now, keep in mind that we have the minus sign. I'll put that at the front. Now, what we can do is we can write this. This cancels out nicely. So we have I is equal to minus pi over 2 times the integral from 1 to -1 of 1 over 1 plus u squared du. Now, we can use trigonometric substitution over here to find out that we will get pi over 2 times the arctangent of u with the limits 1 and -1. If we work this out, we will get, if we put in these limits, we will get pi over 4 plus pi over 4, which then becomes, of course, we have to put this in here for us to actually get the pi over 4 plus pi over 4, but just keep in mind that this minus sign is necessary for this. We could also write it as minus pi over 4 minus pi over 4, so yeah. So then we will have minus pi over 2 times minus pi over 2. Then we know that I is just equal to pi squared over 4. And this will be our answer. So we have found that the integral from 0 to pi of x times sine of x over 1 plus cosine squared x dx is simply pi squared over 4. Yeah. So I guess that will be it for this video. I do hope that you have realized King's rule. It's a really neat trick in calculus, and I really like it. So I do hope that you have gained something from this video. So yeah, I'll meet you in the next video. Thanks for watching.